found in front of you, and that is plaster of Paris. Why it is called such? Because it is the calcium sulfate hemihydrate powder. Plaster of Paris. Paris. Yes, Paris, because it was produced in an was the first to be produced on a very large, massive scale, industrial scale in the city of Paris. Okay. Now, plaster of Paris is called that because the calcium sulfate hemihydrate powder was first produced in industrial scale in Paris. Actually, there were huge or vast deposits of gypsum near Paris. Now, it produced some of the calcium sulfate hemihydrate. Hemihydrate is half the number, half the molecule, of very high quality and purity. So, when it was heated, making it well suited for medical and construction. So, all the plasters, yes, the white color, that solid plaster which the doctor puts around, okay, whenever a person fractures fractures a bone and all. So, it is nothing else but it is calcium sulfate hemihydrate, and that is known as plaster of Paris. It cannot be easily broken because it was of a very high quality and very high, you can say, highly pure also. So, gypsum deposits near Paris, calcium sulfate deposits near Paris produced the calcium sulfate hemihydrate, which came to be known as the plaster of Paris later on. Now, how is it prepared? So, how is it prepared, children? When gypsum is heated, very important, gypsum is heated to a temperature of 373 Kelvin. Now, it was having how many molecules of water? 2 molecules of water. So, when it is heated to a temperature of 373 Kelvin, it became calcium sulfate. It lost few molecules of water and it became calcium sulfate hemihydrate. Okay, hemihydrate is half the molecule of water. Now, this calcium sulfate with half of the molecule of water came to be known as the plaster of Paris, the normal plaster of Paris. Yes, so it is a white powder that the doctors, okay, surgeons would be using to plaster the cast for supporting the broken bones. Okay. Now, when plaster of Paris, that is the calcium sulfate hemihydrate, is mixed with water, again a very important property now, when it is mixed with water, it reacts, it will react and it will change back into gypsum. So, plaster of Paris, when it absorbs water, it is mixes with water, it again changes into gypsum, forming a very hard and solid rigid mass. So, this you have to remember. Yes, children, all these idols, all this work is just plaster of Paris. Yes, we say that we've got the plaster of Paris done, the sealing. So, the chemical formula calcium sulfate hemihydrate indicates that 2 formula units, how many? 2 formula units of calcium sulfate share 1 molecule of water. Yes or no? There are 2 molecules of water. So, if like this calcium sulfate plaster of Paris, when combined with water to form an again gypsum, that means what does it indicate? It indicates that 2 formula units of calcium sulfate will share how many molecule of water? 1 molecule of water each. So, it is used, this plaster of Paris is used to make toys, decorative materials, idols and so many to smoothen the surface, okay, of the ceiling and all. So, from plaster of Paris, when it reacts with water, again we can obtain gypsum. So, here you can see this, I was saying that this calcium sulfate half molecule of water, this one, okay, just half, indicates that it will share 1 molecule. Okay, so this will share 1 and this is going to share the another water molecule. Okay, so when from plaster of Paris, when it reacts with water, again gypsum can be obtained. Thank you children for being with me in a very important session on, yes, we have learnt about washing soda, baking soda, yes, and about sodium hydroxide, the chlor-alkali process. I hope it was an interesting session about salts, and any kind of doubt can be put forward in the next lectures. Thank you.